So up next is Mckenzie Elmer, and I gotta say, she found the story. Like, you know, a lot of you guys make fun of me for talking about a certain topic a lot that involves theoretical climate manipulation long off in the future, and that I bring it up too often. But I think that a real serious current issue that is really at the core of whether or not we, you know, successfully transition to a clean energy economy and avoid some of the worst consequences of global warming is about the ability to take clean, intermittent sources of energy and effectively store it. And that sounds relatively simple, but it's obviously from a physical and chemical point of view very difficult. And then also from a natural resources, social justice, carbon life cycle point of view, it's extraordinarily complicated too. And I think Mckenzie found a really interesting topic here that's super important. And with that, I will throw it over to her. Talk about lithium.
Hi, I'm a storyteller. Ever since I was a kid, I loved writing and learning about the environment, and I really didn't like bullies, so I became a journalist. I spent the last 6 years cutting my teeth, covering everything from crime, courts, politics, immigration, academia, in these newsrooms you see before you, except that's as far as I got at the New York Times before security told me to leave. So I felt like to become a really good environment reporter, I better become familiar with the science, and I found that outlet in Scripps. So if the global economy doesn't figure out what to do without, or how to function without greenhouse gases, we face a certain climate change catastrophe. Lithium is not a renewable resource, but it's a rare earth metal, and it's a necessary component of powering our world on renewable energy. In September, California passed Senate Bill 100, which mandated that the state run on 100% renewable energy by 2045. However, utility companies are struggling to power the state when the sun isn't shining and the wind isn't blowing, and that's where lithium comes in. This is lithium in its raw form. It's used to make batteries that can store energy for a lot longer than most other technologies. The metal is inside of your iPhone, your laptop, your Prius, a Tesla. It's the third lightest element on the periodic table and can store a lot of energy for its weight, which allows your technology to be portable. But the battery-ready lithium we consume is found thousands of miles away from California. It's found here, in the Atacama Desert of northern Chile. Mining lithium comes at a cost to the people living on the lithium-rich land. So in April, I traveled to the Atacama to unwrap this question. Can California truly claim it's reached its goal of 100% renewable energy if it uses a non-renewable resource to get there, especially if it's at the expense of other communities? And here is what I saw. I created a video from my experiences there, which I will play for you now, and it also allows me to sit down for a while.
Juan Cruz lives in the driest desert in the world. He's worked among the remaining orchards of the Atacama Desert in northern Chile for most of his 88 years. Here it rains just 1 to 2 inches per year. The snowpack from the Andean mountains above melts in summer, feeding the rivers that cradle the salt basins below. These orchards in the desert oasis town of Toconao once grew fruits and vegetables to feed thousands of hungry workers at nearby copper mines. People say there is too much drought to farm the old way, when irrigation was done by flooding the land.
Sí, ahora pero que se está como secando, había más agua. Había más agua cuando yo conocí el salar.
One of the biggest threats to the desert's water supply are the lithium mines in the salt flats just south of town.
Chile is one of the world's leading producers of lithium. the stuff that goes into all of our smartphone, laptop, and electric car batteries. It's the nearby Andes Mountains that make these mines possible. Over millions of years, minerals from the mountains leach into the ground. Then they collect together and form huge salt beds, rich in lithium, sulfate, potassium, and boron. Companies like SQM pump water up through the beds and store the mineral-rich liquid in large ponds. From there, it's up to the sun to do its thing and evaporate away the water, leaving the minerals and salt behind. And nowhere evaporates better than Chile. Those are pretty.
Not everyone thinks so. There's growing opposition in Chile against lithium mining, but the global economy is scrambling for it.
The demand for lithium set to increase over the next decade or so. Where's all that going to come from?
That when you look at what the lithium majors are saying, they're all planning now for at least 1 million tons of lithium carbonate equivalent demand by 2025.
Mining has left deep scars on Chile's landscape already. 1.3 kilometers deep and 5 kilometers long, for instance, the size of Chile's Chuquicamata, the world's largest open-pit copper mine. The Chilean government doesn't offer free tours of the lithium mines like they do copper. Instead, lithium is tucked away behind guarded gates, kilometers away from any inhabited place. Mining lithium really means extracting water. Some of the biggest companies, like SQM, are authorized by the Chilean government to extract 47 billion liters of that water per year. Because the water is taken from underground, the scars lithium mining will leave are harder to see. Laguna Chaxa is a protected salt lagoon 30 kilometers north of the largest lithium mine. Flamingos flock here to spend 14 hours per day filter feeding on plankton and algae that spawn in these pools. Naturalists say they notice water levels are dropping, but they can't prove it. The mining companies are in control of the monitors and data collection. Naturalist Manuel Silvestre teaches tourists that flamingos and plankton were here before humans. What we are caring for, he said, is the grandfather of our grandfather. Indigenous people here hold this spiritual connection to water. As demand for lithium increases, it may be lost forever. These communities want the world to understand this energy irony. That what makes an electric vehicle or renewable energy-powered electric grid possible is not sustainable. That when places like California pass laws demanding 100% renewable power, it comes at a cost likely unrecognized in policies or by consumers.
This state has been using the energy policy not just to move towards clean energy, but also to redress the environmental injustice that has been foisted on our poor communities, our communities of color, for decades.
We are building a bolder future, one with a 100% clean energy grid. A grid that won't poison our children or our planet.
There is hope. Scientists at the University of California, San Diego are developing alternatives to lithium batteries. The US government could invest more in these technologies, giving innovation the push it needs to kick our lithium addiction and curb climate change. Until then, people like Juan Cruz will be left waiting for life's most precious resource to run out.
Okay, now stay with me. I'm going to show you two graphs back to back, but you just got a video, so you can handle this. Okay, so California is still highly dependent on fossil fuels. This graph shows sources of electric energy generation reported by power plants in California. The red bar, the big red bar, represents electricity generated by natural gas. And though natural gas emits 60% less climate change causing CO2 than coal or oil, it's still a fossil fuel that won't fly under the new legislation. The state is banking on growing its renewable energy sector, but there's a big problem: energy storage. Now, this graph shows the difference in electricity demand and the amount of available solar energy throughout the day. It's called California's duck curve based on the shape of the graph. When the sun is shining, solar floods the market and then drops off as electricity demand peaks in the evening. This period between 5 and 7 p.m. is when people are coming home from work, and it's when electricity demand shoots up, forming the head of this duck shape. Because California's electricity grid lacks capacity to store enough solar energy throughout the day, it's filling the gap with natural gas power plants. To meet that demand, utility companies like San Diego Gas and Electric are building massive lithium-ion battery storage facilities like the one you see here in Escondido. When this one was built in 2017, it was the largest lithium battery facility in the world. So the global economy is still highly dependent on this region to secure the lithium we need for all of our products. This chart shows the basics of how lithium is extracted there. The lithium exists underground, as you saw in the video, in salty water called brine. Miners pump the water out into these evaporation ponds. An evaporation process can take up to 2 years, even in the driest desert in the world. And this is a lithium mine, SQM specifically in Atacama. These ponds can be 1 kilometer long. That gives you the idea of the expanse of the plant. The yellow water contains the concentrated lithium, which is corrosive and must be handled wearing gloves. It's important to pause and mention some history because the US has been in hot pursuit of Chile's natural resources since the 1900s. The Guggenheim family made its fortune. This is Daniel Guggenheim. They made their fortune by developing nitrate and copper mining deposits in Chile. In the 1970s, the Nixon administration assisted in a coup to overthrow the democratically elected Chilean president, Salvador Allende, and install militant dictator Augusto Pinochet. The US framed Allende as a socialist who promoted state control of Chile's natural resources, much of which at that time was held by private US companies. Pinochet promoted privatization. He promoted it so much that he gave ownership of SQM, now one of the largest lithium mining operations globally, to his son-in-law, Juan Ponce Lerou. Under his leadership, the company got caught paying off politicians on both sides of the aisle in Chilean politics. And recently, the company has come under fire for contracts it signed with indigenous people. But stock prices have been plummeting on SQM over the past year, and because projects are expensive and risky and take years to produce, and they're just under immense pressure to do so. This chart shows the demand for lithium, which is projected to rise far into the future due to the demand for electric vehicles and battery storage. And many indigenous communities that call mine land home have been in opposition for years against lithium mines. The tide seems to be slowly turning, however. Local Atacama Indigenous Council recently elected a young president who told me that they're restructuring their approach and hiring a team of scientists to provide their own evidence of what's happening to their water table. The US actually has large sources of lithium within its borders, but when an Australian-based battery firm asked the federal government for permission to explore for lithium, US environmentalist groups immediately started a fight, claiming the practice would cause industrial sprawl, unsightly drying ponds, and threaten animals. It's easier to ignore a problem when it's not in your backyard. There are alternatives to lithium for energy storage, but the technology isn't there yet. Large-scale battery storage facilities don't need lightweight lithium. They could operate on other sources like salt, which is abundant within US borders, and it could help ensure domestic energy security for the US. Plus, lithium batteries need other rare earth metals like cobalt, which is found primarily in the troubled region of the Democratic Republic of Congo and sometimes secured through child labor. I think the US government could better prioritize its investments in technology to fix this problem. So where do we go from here? This is a troubling irony. It's certain that lithium is currently key to providing renewable energy and for cutting back on fossil fuels. And like natural gas, lithium is not a solution, it's a bridge. I think we could cross that bridge faster and do less harm if rich governments invested in forward-thinking tech. Policymakers need to lead the way, but consumers should know what's behind the products they use every day and put pressure on elected leaders to find solutions. I'm way over time, so here's all the people that I want to thank. My committee, Dr. Paula Cerevilla, Dr. Corey Gabriel, Dr. Jeremy Martin, Yona and Raul from Chile, who helped me out, the MAS committee, and my little brother, who had to watch my video 1 billion times. And if you want to find my story, I will hopefully be publishing it, and then this is a very self-serving pitch for my Twitter, where I will post a link to that eventually. And questions? No questions? Oh.
So we have lithium, but our environmental policy has stopped that from being mined?
I don't know. I didn't really look at. Corey, what do you think?
The 70% of the proven lithium reserves are within that circle.
It's different kind too. One's brine.
Yeah.
I've got my lithium team in the crowd.
We have some in the US, there's been some regulation, but other than the main burden, I think that the proven reserves would be much higher than the solutions. So that if we're going to ramp up demand to where we need to be in 2025, without that region, there's not enough proven reserves in the world. I think
It's a good question, though. I'll pursue that.
Regarding the sort of potential solutions, first of all, there's a lot of work being done right here at UCSD on recycling. So that cuts down the demand. And you don't use lithium, it's lithium compounds that you get. Lithium itself doesn't exist in nature as a pure metal. So as if you recycle, and then if you can also get lithium from rocks, certain kinds, it's called sapodamine, but it doesn't involve water and up tables. So there are lots of possibilities, and you've alluded to some of them. The current system does pretty significant environmental damage. And some people think that lithium will continue for a long time as needed in these storage batteries. Other people think it can be. So it's a very good topic, and certainly the social justice aspect has not been looked at in any serious way.